Okay, so we're going to quickly review parallel and perpendicular lines, and this is from Algebra 1. So remember that in order to determine if two lines are parallel or perpendicular, one thing that we can do is use their slopes to determine this. So if two lines have the same slope, then we can say that those lines are parallel. So if you have a slope, of 3, and your other line also has a slope of 3, then these two lines are parallel. Okay. Perpendicular, the slopes have to be negative reciprocals of each other. So if I had 3x plus 4, I would need to negate that, so it'd be negative, and I need to take the reciprocal of 3. So we would have negative 1/3 x plus 4. And so those are perpendicular. Okay, so that's what we're going to focus on today. So determine if the lines are parallel, perpendicular, or neither. So our first step is to determine the slope of each line. Well, they are in standard form, so I need to rewrite them in slope-intercept form. So I'm going to subtract 2x from both sides, divide by negative 3. So we get y equals 2/3 x minus 4. So we have that. Put that up there. Line B is 4x plus 6y equals 12. And so I would do the same process, subtract 4x from both sides. I apologize, it's a little messy. And we get negative 2/3 x plus 2. So here we have our equations of the line. And so if I look at my slope, my coefficient of x here I have 2/3, here I have negative 2/3. Well, they're not the same slope, so they're not parallel, and they're also not negative reciprocals. One of them is positive, one is negative, but they're not the reciprocal of each other, so they're not perpendicular either. So these lines do not have don't have neither of those relationships. If we were given the graph, we would do the same thing. We would just find the slopes given the graph. So it's kind of faint on your paper, but I would do my rise and run. So this goes up 2 over 3. So my red line has a slope of 2/3. My blue line, I can go from this point to this point, which is negative 3 over 2. So the blue line slope is negative 3/2. Well, if I look, one's positive, one's negative, and they are reciprocals of each other. So I can say that these two lines are perpendicular to each other. Note, I could not just say that by looking at that, oh, I think that's a right angle, so they're perpendicular. That is false. You have to really check their slopes to make sure that they're perpendicular. So here we have an example 3. We want to write a linear equation that is parallel to the line y equals 9x minus 3, goes through that point. So we have our slope is 9, and we have our point here. So we have slope, and we have a point, so we want to put point slope form. So remember, point slope form from Algebra 1 is y minus y1 equals m times x minus x1. So I would put what I know into my formula here. So I know that's y is 7, x is negative 1, slope is 9. Then we need to put it back into slope-intercept form because that is the form that they gave us. So to do that, I'm going to use the distributive property and then add 7 to both sides. And so here is my linear equation that follows the slope and the point. So we want to write a linear equation. We want to know it's going to be perpendicular to this and goes through that point. So perpendicular is important here. So the first thing we need to do is write our linear equation in slope-intercept form. So we're going to get 2/3 x minus 15. So that tells us, because we want it perpendicular, our slope is going to be the negative reciprocal. And we're going to use the point that they gave us there. So now that I have all the information I need, I have a point, I have a slope, I'm going to put it in point slope form. All right. So now we're going to have to put it back into standard form. We're going to need to get rid of that fraction first, so I'm going to multiply both sides by -2. So we have 2y minus 6 equals -3x plus 4. So when I do that, 2y minus 6 equals -3x minus 12. I'm going to add 3x to both sides while I add 6 to both sides. And I realize I did more than one step there, but that is our final answer. The reason we want our answer in standard form is because we were given the problem in standard form. So that is why we need to make sure that the two are the same form. So we're going to practice this in class on Monday.